So, good evening to one and all. Is the AV clear for everyone? Say. Thank you. So, let us start our today's session on the following. So, before going to start the session, let me ask one question that do you have any queries with regard to the previous session, what we have discussed on the degeneracy of transportation problem? So far, what we have taken earlier. So, the objective of today's session is mainly on degeneracy of transportation problem and how to resolve it when it occurs in checking the optimal solution. That is the first concept I wish to take for today. If supply and demand values are same, such case usually won't happen in general because both gets cancelled at a time. Actually, that type of situation will happen at the end for the last cell, isn't it? So that the same value will be allocated, that row and column at a time gets cancelled. So if you say, if you have a cell happening like this is the value X, the cost. Here the supply is 200 and demand is 200. So you are cancelling at a time, the total thing gets cancelled. So in one way you are reducing the submatrix. Right. So you please quote that, then we are going to discuss on that concept too. Right. So we will cancel both the things because we are doing the subtraction there, isn't it? Right. So the second thing we wish to take is maximization in transportation problem. So on discussing with these two topics, we will close our discussion on the transportation problem. So in tomorrow's session, I am going to take the concept of assignment problem, and simultaneously I will take the doubts on transportation problem itself, so that we will end up our thinking on linear programming chapter. So from Thursday onwards, we are going to start real analysis. So maybe I am going to plan on Saturday one more session with regard to this linear programming problem. So for doubt clarification, I hope that will be suitable for everyone. Is that fine? So as per your need, I am going to take more session on it because I felt that I have covered the topics in detail with regard to the examination point of view. I hope so. Right. I think after having these class sessions, you are able to solve the previous year questions. That's my feeling. So let us start our session. So I am going to take the following problem now. So I have the table with allocation. So I am not giving the problem itself. I am taking the solution part of the problem obtained by VAM, and I am checking for the optimality, right? So the values given are 7360, 4680, 5840, then 8430. And the corresponding supply and availability demand requirements are Here you have and coming for the allocation part, I have taken the values as then I have taken the values as here 5 and here 2, and then I have taken 3 here. So this is the problem which I have considered to check the degeneracy under optimal condition, right? So the solution is obtained by WAM. A dummy column is introduced to make that the problem gets balanced, and the values in the circle indicates the allocation values, and 7, 3, 6, 0, etc. These are nothing but the cost values of the matrix. That is my problem under consideration. Is this fine to all? Please take a note of that. After noting, you please inform. So is it properly visible to all? Right. So first of all, let me check whether the solution is feasible or not. So can we say that the solution is feasible here? Right, because you can check for the number of allocations, how many they are. Right, so it satisfies the feasibility criteria. Now, if you check for the cost of transportation, 3 into 5, 4 into 5, 6 into 3, 8 into 2, 4 into 5, and 3 into 3. Summing up all these values, the cost of transportation would be 98. Could you check on that? The cost of transportation. All of you, please go through it once. Right. So I think everyone accepts with this number. Any queries, please? Fine. So in the optimality check, we are not going for this supply and demand constraints, however. So let us verify whether the cost of transportation 98 is optimal or not. That is our criteria. So what happens? We are going to calculate the U and V values for it. So straight away I am computing. So is it required for you to write the computation process again, or straight away can I write the values? Can I write the values of U and V straight away? Fine. So I am going to write the values like this. So the values have come like this. And for here, the values will be taken as usually while calculating the U and V values, always we take that U1 is equal to 0. Here U2 became 0. Can you observe the difference here? Yes or no? Why? Because in the second row you have 3 allocations. So in order to meet the required criteria, if you put U2 is equal to 0, the cost value is 8, so V3 is taken as 8. Cost value is 6, V2 is taken as 6. Cost value is 4, V1 is taken as 4. So that the rest of the computation part will be easy. So that is one trick here while calculating UV and VJ values. As and when a row takes more than 2 or 3 values, So at that position, you take U2 or V2 equal to 0. So that computation process will be convenient. Are you getting the thing? Say. Right. Now, after computing the values using the basic cells, let us go with the non-basic cells. So we are going to calculate the penalty defined by Ui plus Vj minus Cij. You are going for everything. For 7, 4 plus minus 3 minus 7, so that you are calculating. Now tell me wherever you get a positive value in the whole table. I think that you are able to do on observing the tabular values of Ui and Vj. Did anyone feel difficulty in getting these things? Please tell. Anyone has any doubt with regard to the calculation of the penalty values? How we are getting a positive value in them? To anyone, I will explain again. For the non-basic cells, how we are going to calculate the penalty values. Say. So if you go for this one, 4 plus minus 3, 1, 1 minus 0, 1. So you will get a positive value here. Right? So if you take this non-basic cell 6, 8 plus minus 3, 5, 5 minus 6 minus 1, this is negative. So the positive value occurs at this position. Again, if you calculate here, 4 plus 0 minus 0, you will get the positive value 4 here. So for U1 V4, you have the positive value 1, and for U2 V4, you have the positive value 4. Did you find that any other positive value comes for the rest of the rows? Any place? All of you agree with this? Say yes or no. Right. Now, among the two positive things, 4 is the most positive one. So I need to allocate something here. So the necessary changes will occur with the rest of the table that I should do. So among the two positive ones, I am selecting this thing. So this is my mark. So I have to construct a closure path here to go for the allocation. So this is my mark. I must travel from basic cell to basic cell. So this is the path available to me. Is this clear for everyone, the path? So here I got 0. Here the value is 2. Actually, I need to mark this. Here the value is 5. And the value is 2 here. So plus, minus, plus, minus. This is the thing I got. So what happened here? The smallest of the negative cells is nothing but 2. So I am going to remove 2 from the cells, and wherever I got the plus sign, so I should add the value there. So the necessary change will take place that here I am getting the allocation 2. This allocation becomes violated, it becomes violated, and it becomes 7 in the allocation. Please check that. Any queries so far? Any doubts, please? Say. Right. Now, as and when we go for an allocation, usually one basic cell will be converted into non-basic, and one non-basic will become basic. But what happened here, since two cells have the equal allocation number, so at a time two basic cells have become non-basic in this situation. So what happened, initially the number of allocations property is satisfied, but while checking the optimality, in doing the necessary adjustment, at a time the solution becomes not feasible because the number of allocations are not tallied. Accepted? Yes or no? I think everyone is getting the concept right. Fine. So how many basic cells are required here? Please tell. You have total 8. 7 must be there, but you have only 6 basic cells, isn't it? Right. Now you have to allocate one basic cell again. So what happens in the first case, what we have discussed earlier, degeneracy in the beginning stage, we allocate epsilon for the least cost cell in the table. Here what happens, since the degeneracy is occurred in a loop, so the loop where you have considered, this is already allocation made, this is already allocation made, you have 2 cells vacant here. In the 2 cells, you should pick one cell and there you are going to allocate epsilon. The thing is, since each cell contains the cost value, you are going to allocate the epsilon where the small cost is there. So whenever small cost is there, at that position you allocate epsilon, because our objective is to minimize the transportation cost. If at all 2 cost values are equivalent, in such case you can go arbitrarily. Otherwise we always go with a cell having small cost value and there we are going to allocate the epsilon. So what is the criteria here? We allocate the epsilon where you have constructed a closed path and the cells are removed. And in the cells, we pick the cell where it has the small cost value. That is the ideology. Fine? Yes or no? Right. So if you allocate the thing, I am going to erase this. 8 and 0, here I am going to allocate the epsilon. So by adding epsilon, it won't affect the demand and supply values because epsilon is the smallest positive value. Now again, you are calculating Uy and Vj values for checking the optimality as it is. So if you calculate the values, they are going to appear like this. Let me go for myself. So these are the values of U. If you calculate the values of V, they will come like so. In one way, we can say that while calculating Uy and Vj values, please observe in the earlier table you have U1 and U2 values same as it is. As and when the loop gets changed, corresponding U and V values are only changed. So here earlier you have V1, V2 values are 4 and 6. U1, U2 values are -3 and 0. They are retained same. Only the change taken place here and here only. So as and when a closed loop is there, where the allocation is being done, at those corresponding rows and columns only, the necessary changes will take place usually. Accepted? Calculating Uy and Vj. Now, since after doing this allocation, again we are going to calculate the penalty, Pij, for all the non-basic cells. I think you are going to check on this on your own. Could you? Right. So here if you calculate the thing, 6 plus minus 1, 5, 5 minus 4, 1. So here you have a positive penalty 1 appeared here. I think for the rest of the non-basic cells, all values are less than or equal to 0. I hope so. Could you agree? Because you have only one cell is there, you are going to modify this. In other words, you are going to allocate something. So please understand that you are going to construct a closed path. So how the path comes, here you have the thing. So I am going to draw the thing here. Please check on the closed path what I have drawn there. So this modification we need to do. So since the closed path involves epsilon here, which is nothing but the smallest value, so epsilon will be allocated here. Since epsilon is smallest positive value, so it won't affect the other things. There is no need to change the allocations which you have made earlier in this closed path. The only change takes place that here you have allocated epsilon to 0. This allocation will be changed and the allocation comes here. 4 gets the allocation epsilon. Clear for everyone? Any queries, please? That's it. Now again you are going to calculate UA and VJ values. They are going to come like this. So straight away I am going for the modifications. You are going to get the values like this. This is the thing after recalculating UA and VJ values. Yeah. So let me draw the closed path one more time. This is the closed path I got earlier. Now what happens? Here I got the opportunity value, nothing but the penalty 1. So this cell gets a modification, isn't it? Yes or no? Right. So I will write the allocations which are being done there. Here 3 is the allocation. Here 7 is the allocation. Here epsilon is the allocation. Here 2 is allocation. Here 3 is allocation. This is the closed path I got. Accepted? Now starting from this position, plus minus we take. Usually how do we go for a modification? In the negative signed cells, we should take the smallest value, isn't it? So among the negative signed cells, what is the smallest value? Epsilon, isn't it? Because here you have epsilon, 3 and 3. These are the allocations made there. Accepted? Yes or no? Right. So you are subtracting epsilon for the negative signed cells and you are adding epsilon for the positive signed cells. Since epsilon is arbitrary small allocation, subtracting epsilon won't get affected on the remaining cells. So if you subtract epsilon, it will become 0 here, and you are adding epsilon to the plus signed cells, it is epsilon. So in this allocation, earlier epsilon is placed here, it came to this position, rest of the cells being taken as it is. Because if you are adding epsilon, if you want to write systematically, you should write that this is 3 minus epsilon, this is 2 plus epsilon, this is 0, 7 plus epsilon, 3 minus epsilon and epsilon, isn't it? Since epsilon is arbitrarily small value, we are neglecting to write that. Only allocation we are being done, that's all. I hope that it clarifies the doubt. Fine. So after doing the reallocation for epsilon position, if you again calculate Uy and Vj values, so this, sorry, this is the necessary change happens in Uy and Vj values. So if you calculate for the non-basic cells the parity, all the values are nothing but less than or equal to 0, hence optimality is reached. Now if you calculate the transportation cost here, right, how it is going to be done? 3 into 5, 4 into 5, 6 into 3, 4 into 7, 4 into epsilon will be neglected, 3 into 3. Now you can sum up the values. The value is 90 because epsilon is arbitrarily small value. We stop counting epsilon there. We should understand one thing, that the importance of epsilon is nothing but doing allocations so that the solution becomes feasible. That's all. So earlier the solution is 98. After going for the optimal check, it has become 90. So obviously and definitely we can say that this is the optimal solution compared to the previous thing. So if you talk of physical significance of epsilon, so as and when the allocations are being made, so for this position D and X, you can supply very small quantity. That's you can say as per the requirements considered. Epsilon is a very small quantity which you can go for a supply for D to X. In other words, you can go for a transportation from D to X as and when a situation happens. Otherwise, we neglect that. That we can call of physical significance. Okay. Any more questions, please? So if the concept of degeneracy is clear for everyone, then I am going to start afresh the concept of maximization. Can I proceed? Right. So usually, as and when we consider a transportation problem, you have a matrix containing the cells. Usually, these cells are nothing but cost values, isn't it? So, maximization of transportation is nothing but maximizing the profit. So if you talk of a physical situation, let me say I have some factories. I will take a problem on this, and the factories are producing 3 varieties of products. Now, since I am on the manufacturer side, for each product, I can fix the selling price, isn't it? Yes or no? Right. So, I fix the selling price for each product. Since I am the manufacturer, to produce a product, it must undergo some process like labor, machinery, refinement, etc., etc., etc. So for each stage, I know what is the cost. Let me say, to manufacture one single product, it must undergo for 3 stages for the procedure. So for each stage, I know what is the cost for that stage. So what happens if I produce 1 unit of product? So stage 1, stage 2, stage 3. At each stage, I know the cost. So stage 1 cost, stage 2 cost, stage 3 cost. Summing up all these values is nothing but the total production cost. Accepted? Right. So how the profit comes? As we know, profit is nothing but selling price minus cost price. So here the profit is nothing but for 1 unit how much selling price I fixed minus the total production cost. So what happens for a given data, apart from framing a table having the cost values, I will frame a tabular data for profit values. So earlier we call it as a cost matrix. Now we are going to call it as a profit matrix. Now what happens? This profit matrix will be converted into a cost matrix. And we apply all our procedure on this because the procedure is described for the cost values. So how we are doing this? In the profit matrix, we take the maximum value and we subtract all these values from it so that you will get a cost matrix. So every value in this is subtracted from the maximum element in that matrix. The result is nothing but the corresponding cost matrix. Okay? Are you getting the thing or not? I will say that we can call it as, apart from cost matrix, the loss matrix we call it as. If you subtract the maximum profit, the result is nothing but the loss matrix. Fine. So on this loss matrix, we are applying the procedure. If the loss is minimum, it indicates that the profit is maximum. Yes, I will take the example. Before that, I am giving the idea. Okay. Is it fine for you? The concept what I am giving. So if you talk of a procedure in a simple manner, I have a data. From the given data, I am framing a table which indicates the profit values. From the profit values, I am getting another matrix, subtracting all the values from the maximum entry, which indicates the loss matrix. I am applying the procedure on the loss matrix. So minimizing loss is nothing but maximizing profit. That was the whole concept. Clear? The ideology is clear, then I go with the procedure. Can I continue? Right. Now this is the problem. I am going to take an example. The maximization and the transportation problem. So I have the factories F1, F2, F3 and F4. And I know the stages. Transportation cost for S1, S2, S3. And I have other costs, production cost and raw material cost. Then I have the supply and I know the sales value and the requirement. So let me fill the gaps in that first. Then I have letter So please note down the problem. After noting, you please inform. So if you look at the problem, the ideology behind it is I have 4 factories, F1, F2, F3 and F4. Here you need to understand it is sales price. So each factory has 3 items, S1, S2, S3. So for each item, whatever the item you take, either S1 or S2, S3, I know what is the production cost for the item, what is the raw material cost for the item, for each item, what is the transportation cost. Please understand that the values are taken per unit. So what is the production cost per unit? What is the raw material cost per unit? What is transportation cost per unit of S1, S2, S3? And this value indicates if I want to sell the item S1, for 1 unit, the rate is 34. You can call rupees or thousands. Let us take rupees. For S2, 1 unit selling price is 32 rupees. Here 31 rupees. And this indicates that what is the requirement, in other words, what is the demand of S1, demand of S2 and demand of S3 in market, and what is the availability for the factory, this item, this item, this item. That's it. This is the whole ideology. Is that fine? You can call S1, S2, S3 as sales reports or sales items, whatever you can call. Is this concept clear for everyone? Do you need any elaboration over the tabular data? To anyone, is that required? Please tell, wherever you got a confusion. Right. Now, what is the first stage? On basing the tabular data, I must frame the profit matrix. What is meant by a profit matrix? What is the profit I will get from the factory and from the sale S1 or the item, right? So if you frame the table, the values will come like this. I have 4 factories. I can call it as F1, F2, F3, F4. I have 3 items sale, S1, S2, S3. Because these 3 items are available in each factory. Now, the cells here indicate the profits. So F1, S1 indicates that the profit I will get if I distribute the goods from factory 1 to sale depot 1. So F1, S2 indicate that the profit I will get if I distribute the goods from F1 to sale depot S2. Clear? So in this way, the profit matrix will be explained. Is that clear? Or I have a question? Right. Now, I am going to fill the values here in this table. So what is the thing here? Profit is equal to selling price minus the total cost. Accepted? So if you take S1, the selling price of S1 is 34 minus C. If I take the factory one, you need to add all the three values because transportation cost of S1 is 3, raw material cost is 10, production cost is 15. On summing up the three values, you will get 28. So what is the profit here? 6. So I should take 6 here. Are you getting the ideology? Yes or no? Right. So if you take S2, so here 15 plus 10 plus 1, so 26 you should take the cost. What is the sale of S2? 32. So 32 is the selling price. The profit is 6. So I should take for F1, S2, the value is 6. Right. So if you take F2 and S1, see 18 plus 9 plus 9, so the value is 36. Selling price is 34. The transportation total cost is 36. The selling price is 34. You have a loss here, so you get minus 2 here. So for F2 and S1, you will get minus 2. Are you getting the logic? How the values are going to be filled? You please ask any questions for anyone. So for each item, I am taking the selling price minus what is the transportation cost between the factory and the sale depot. That's I am calculating. The difference will be taken as the profit. Clear or not clear? Fine. Now, for every transportation problem, we are going to check whether it is balanced or not balanced. So if you get for the requirements is nothing but demand. What is the total demand there? On summing up the last column values, what is the total demand there? 350. Here supply is nothing but the availability. What is the total supply here? 310. So is it a balanced one? No. So by introducing a dummy row or column, we are going to make it balanced. Then we are doing the necessary things. So if you clear with the ideology, since you know how to fill the profit matrix, I am going to write the profit matrix straight away. Can I? Right. I am going to erase this. So the profit matrix will come like this: S1, S2, S3, F1, F2, F3, F4. The values are taken as 661 minus 2 minus 2 minus 4, then 322, then you have 853. If you go for supply and demand constraints, they will come as 80, 120, 150. This is the demand or requirement. And if you call it as supply or availability, you are going to get it as 10, 10 and 150, 50, 100. Now tell me what I am going to do. I need to introduce a row or column. What I should do? Please check on that. Here you have a less thing, right? Right. So that you need to introduce a dummy factory here. Factory dummy, where all the depot distribution is 0 there. It becomes balanced. You will get 40 there. Now you can check on that, whether it is a balanced one or not. If everyone agrees with this, I go to the next level. Any queries for anybody so far? How to establish a profit matrix and how I am introducing the dummy row there? Okay. So this is the profit matrix. From this, I am calculating the, or I am obtaining the relative loss matrix, because my aim is I need to maximize the profit. Because our algorithm, the transportation problem algorithm, is meant for minimization. Whether you apply Northwest method, VAM, or whatever it is meant for minimization. So how to get the minimized procedure applied here? So I am converting the profit matrix into loss matrix. So by applying the procedure, if I minimize the loss, it indirectly implies that I will get the maximization of profit in the distribution of goods. So if you check that in the whole table, what is the maximum number there in the values of the profits? 8. So I am subtracting all the values from 8. So 8 minus 6, 8 minus 6, 8 minus 1, 8 minus half, minus 2, like that I am doing for everything. Is that clear? Right. So I am going to do the modification straight away. So initially it is a profit matrix. I am writing another table by having the relative loss matrix. So I am going to erase these values. The corresponding values are going to take place as 2, 2, 7. Then you have 10, 10, 12. Sorry, 5, 6, 6. And you have 0, 3, 5 and 8, 8, 8. Is it clear for everyone? This is the loss matrix which I got. Multiply each row by -1, we will get loss in each location path. So can you say that that will give the same values as earlier? Because you have a dummy row. On the dummy row, I have taken 8, 8, 8. That is somewhat different, right? Fine. If you do like that, you have a problem in applying the procedure, isn't it? If you go for the least cost cell method, what you are going to do, and if you go for VAM, how you are going to compute the penalties. Is it somewhat different? So let us stick on to the procedure right now, then we discuss of that case. Right. Now you are going to find the feasible solution for this loss matrix by applying any one of the methods, Northwest corner rule or matrix minima method or VAM, whatever it is. Since you know how to apply the procedure there, I am straight away applying VAM. I am finding the initial solution. So can I write the allocations there straight away? right? So here the allocations come like this. So this is the solution obtained by VAM, the initial solution, and the things will come like this. Here 40 is allocation, here 110 is allocation, then you have 50 is allocation here, later you have 80 and 20 here, then you have 40 is the allocation here. Right. So you can count on how many allocations are being made. So you can say that it is a feasible solution, right? Because you have 5 rows and 3 columns. There must be 7 allocations, and you got 7 allocations there. It is a feasible solution. Now you are going to do the corresponding optimality check by Modi method by calculating Uy and Vj values. I am going to take the values like this. The corresponding values will be taken as and here you have for V1, V2 and V3 the values will be taken as these are the values. So coming for the non-basic cells, you please tell where you have an opportunity positive to improve. You please check the case and tell me. For the non-basic cells, you calculate the penalties and tell me the value where we need to go for a modification there. Which cell is to be modified? Yes, U3 and V3. So I hope that everyone agrees with that. Fine. So you have a closed path coming like this. At this position we are doing the allocation. So plus minus plus minus. Here you got a value 50. Here you got the value 10 and here you got the value 110. And what is to be done there? The smallest among the negative values is 50. We need to subtract 50 from the values and add the value here. So I say that it will become 60. So this allocation gets cancelled. Sorry, 40. Right, 40. So this will become 90. It gets cancelled. I need to allocate 50 here and it will become 160. So please check on that. All of you agree? Yeah, earlier it is 10, it will become 60, right? Sorry. Is that fine now? Right. So after doing this modification, again you are going to calculate the respective values of ui and vj. Shall I continue for that? And obviously I can say that the solution is optimal. From this allocation you are going to do, and you are going to say that the optimal solution you have arrived at this position, so that the necessary profit is maximum, because the solution which you have allocated here is optimal after doing this. So here I want to conclude about the procedure, what we have done so far. Clear to all? Right. So if you're interested, I am going to take one more problem on this, of this maximization case. Can I? Right. So just hold on a second, I'm going to take that. So I want to take the tabular data straight away. So without being construction of the profit matrix, so straight away can I write the profit matrix? Because you know how to compute the profit matrix, right? So I have the plants 1, 2, 3 and sales offices 1, 2, 3, 4, 5. I have the supply and demand as well. And then you have corresponding supply and demands are given by and the required capacity is given by and you can verify whether it is a balanced one or not. I just want to introduce 80, 100, 75, 45, 125. That's it. Yeah. Is that a balanced one? No. So what is the value I need to do there? I have to introduce a dummy column or row. If this side you have a discrepancy, you need to introduce column. If this side you have a discrepancy, you need to introduce row. Right. So column I need to introduce. So what is the value I should take there for the dummy? 50. Right. So this is 6 dummy. The value is 50 here. The necessary values will take place. Since we have a profit matrix, from this you are going to construct the necessary loss matrix. I think you know how to compute the loss matrix, right? What is the highest value in this one? The profit matrix 14. So all the values will be subtracted from the value 14. So the necessary changes will take place like this. So this is the profit matrix. Is it clear for everyone? Right? So can I write the loss matrix straight away by doing the subtraction with the highest element? Okay. The values will come like this. Just hold on a second. 53899, 15, 11, 13, 5, 13. Then you have 6, 5, 4, 0, 10. And the rest of the things will come as 14, 14, 14. Isn't it? Right. So straight away we are going to write the initial feasible solution by applying the VAM. So I am going to write the necessary allocations also here. So here in this matrix, I am going to do the allocations like 50 here and 100 here, the allocations. And the next stage, $25, $125, $50 will be taken place. And here you have this was the thing I have done for the allocations part. So please take a note of the allocations. And some others will do in a sense that apart from writing the highest element 14, 14, 14, the dummy row or dummy column, whatever you say, they first compute the relative loss matrix and there they simply introduce 0, 0, 0. Clear? Because there is the highest element apart from 0, 0, 0. So is closed loop possible in basic allocation? Why not? Just hold a second. Yeah, just I have to do a modification. Sorry. Here it is 125. Then you are correct, right? So that the value should be value. You should say that the supply demand value should coincide, right? There 125 left vacant. Now it gets balanced. Accepted now the total value? Because if I have written 125 here, the sum must be equal to 100. It gets violated here. It is 100, it is 125, total will be 225. That won't get satisfied there. So the 125 comes here. You can check for cross verification that whether the supply and demand is acceptable or not in that posting, the relative posting, what I have done. So in general, it is not possible. So did you find any closed loop here straight away? For allocation of basic cells. That's what I'm asking. Did you find any closed loop here? No, straight away there is no closed loop. That's it. As and when there is an opportunity cost, then only you can find a closed loop. You are building a closed loop there. So let me go for the remaining procedure. Shall I continue? So now after having this basic feasible solution through VAM, you are going to calculate the values of UI and Vj. I think you know how to calculate them. And straight away, I'm going to write the cell where a modification needs to be done. So I say that at this position, you are going to do a modification. I will write the values also there for your understanding. -10, 0, -9. These are the values of U. And if you go for the values of V, they will come like this: 15, 13, 13, and you have 9, 13, 0. Because 0 is taken so that the dummy is taken as 0, otherwise you can take it as 14. So I am going to write, apart from 14, 14, 15, I am going to write it as 0, 0, 0 to avoid computational difficulty. I will write like this. So I have introduced the dummy row by using 0, 0, 0 after construction of the loss matrix to have the computational convenience. Because if it is 14 there, then you are going to do the U and Vj values in a different way, right? That is also acceptable. Earlier you have done by keeping 8 itself, the maximum element in the previous problem. So here I am doing the other procedure that straight away, without introducing the dummy row or dummy column, first calculate the loss matrix, then make it balanced by simply introducing 0, 0, 0, so that calculation of U and Vj will become somewhat easier. Because for every problem, we know different methods, right? In the previous problem, after subtracting with the highest element, you have done. So here, apart from introducing the highest element there, I have written 0, 0, 0. So I have introduced the dummy row after calculating the loss matrix, not from the profit matrix. So the dummy row is not introduced at the first, it was introduced after calculating the loss matrix. That was the idea. So that computation will be easy. Clear? Right. So if you observe that here you have a positivity for this position. So there you are going to improve the modification. I think I need to go for, yeah, I think here I need the positivity. Could you check the positive value there? Yeah, at the position 5 you have a positivity. So if you construct the closed loop there, so for 5, this is the value where you need to go. The cell will come like this. Let me write here only. Here you have the value 25, which is allocated there. Here you have the value 5, which is allocated here, and you got the value 45 you have allocated here. Please understand that while constructing the closed path, this cell I am not considering. Please understand that the closed path must contain even number of cells, not odd number of cells, because we should have plus minus criteria alternatively. So to satisfy that, as and when you build a closed path, it must contain even number of cells. So the closed path is constructed in such a way that this basic cell is excluded. I have moved in this way. So the cell where need to do allocation 25, 5 and 45, this allocation is skipped. Okay. Please check on that. Accepted. Now, if you take the symbols plus, minus, plus, minus, the smallest is 25. So 25 must be subtracted here and added here. So I am going to take 25 here. 25 will get added here, it will become 30. Completely violated, and it will become 20. The allocation accepted. So if you go for the optimality check, this is the optimal solution. I am skipping writing the part of Uy and Vj again and saying that it is the optimal solution because you are going to do it anyway. Is that required for you to write one more time writing Uy and Vj by saying that this is the optimal solution? Right. So after having this, since you know that the loss value is minimized, I need to know what is the maximum profit I will get, isn't it? Yes or no? Because my intention is the problem should have an answer. Since my target is to maximize the profit, I should know what is the profit I have obtained. Say yes or no. So using this final table, how to get the profit value? That thing I must know. Right. So since I got the plants and sales offices, so for the convenience, I will say that this is plant A, plant B, and plant C. For the convenience, I am writing. Now see, for plant A, where you have the allocations for the sales offices? 1, 2, 3, 4, 5, 6. We have 6 sales offices. Where are the allocations for plant A? 1 and 2, isn't it? So for plant A, I can have the distribution to sales office 1 and sales office 2. The allocated value is 50 and 100, isn't it? The units allocated are 50 and 100 in the table. So for A, I have 2 plants, sales offices 1 and 2. Here allocation is 50, here allocation is 100. Now to get the profit, I need to multiply the profit value, right? So at the first, you have built a profit matrix. Can you recollect the profit matrix first, what you have written? Right. So for the first plant, sales offices, here the profit is 9, here the profit is 11. Can you retrieve the values from the first table? Could you check on that? Are you getting the thing what I am saying? Any queries, please? So here the profit is 450. Here the profit is 1100. So these are the profit values. These are the allocations what I have done here. And for plant A, I have 2 sales offices. Here the allocated units are 50, allocated units are 100, and the profit I get is 9 rupees, 11 rupees. So the total profit is this here. Now coming to plant B, where I got the allocations for plant B, sales office 4 and sales office 5. Dummy we should neglect, right? These are 25 units allocated here. These are 125 units allocated here. Now what are the corresponding profit values from the earlier one? From the profit matrix. So what is the profit for sales office 4 and sales office 5 for the plant B? 9 rupees and 1 rupees. So here 9 rupees is profit, here 1 rupee is profit. So this is 125 rupees profit. This is 25 nines. What is the value? 225, isn't it? Accepted. Now I have plant C also there. For plant C, I have the allocation for 1, sales office 1, then sales office 3, then sales office 4. Here 20 units allocated, here 75 units allocated, here 30 units allocated. And what are the respective values there? 8, 10, 14. So into 8, into 10, into 14. So this is 280, this is 750, this is 240. Now summing up all these values, you will get the total profit. It is nothing but 3,170. So in this problem, what we have done, you know how to compute a profit matrix, you know how to get the respective loss matrix, and you can apply the VAM, make the necessary feasible solution. You have gone for the optimality check. You have made the optimal solution. After having the optimal table, the profit will be calculated by means of the allocations value made in the final table and the profit values indicated in the first table. So multiplying these two, you will get the profit of the respective things. Summing up all these things, you will have the maximum profit. That was the whole idea. Clear? I think these calculations how I have made is clear for everyone. I hope so. Any queries, please? Right. So as and when you get a problem like this, the minimum weightage will be 30 marks. You can understand that how much time it takes for computation of all these tables. Say. That's it. So this is the case where we go for maximization in a transportation problem. So far, if you have considered what is our discussion over this transportation problem, initially we have learned two methods. What is that 241? Can you give? One of our friends has given a number 241. Could you explain, please? Okay, fine. So if you have an overview over the transportation problem, what we have done so far. So you have learned about the three methods: Northwest Corridor method, least cost, and VAM. Later you have gone for how do we go for a optimality check. That is the first stage. Second, you have learned how to go for the degeneracy check and how to remove the degeneracy in the beginning stage as well as the final stage. And how to go for a maximization in the transportation problem by the construction of two matrices. How to build a profit matrix. From that, how to convert the loss matrix, and we will do that. That's it. So generally, to my understanding, I will say that if a problem is given, in general, all the cost values are positive. Accepted? All the cost values are positive. So if a problem is given with negative values, some of them, I say that if the problem didn't indicate that it is a profit matrix, because in the previous two examples what we have done so far, you can check that the negative values in the matrix indicate the profit, isn't it? So there what we have done, by considering that it is the profit matrix, by subtracting the highest element, so you have obtained the loss matrix and you have done the problem. If the problem didn't indicate that it is a profit matrix, I feel that you just leave the negative numbers which are there, and for the rest of the cost values, you just perform the procedure as it is. So while calculating the penalties or matrix minima method, we simply ignore the negative values and we do the procedure as it is. That is my opinion. As in when a problem is given without indicating that it is a profit matrix. Fine. So I will take a relevant material for you if you are interested and post that. So that's all about this transportation problem. Is this discussion suffice for all of you or the concept? So in tomorrow's class, I'm going to discuss about the assignment problem. That will be very interesting compared to the transportation problem. There you love more. Then we conclude our linear programming chapter completely. So I request everyone to solve the previous year questions and please post the queries in Telegram so that we have a good idea. And I can take a doubt clarifying session as well. I will go to that question also. I will check whether it indicates a mistake in the material, or if it is there, I will give a solution to that also. Right. Yeah. So thanks to everyone. That's all for today. So we will meet in the tomorrow session.